Hey, what are you doing? Not you. You're watching Ham Radio Concepts is what you're doing. And you may be clicking on this video because you're just getting into the amateur radio hobby. Guys, I've been doing this since 2004-ish, 5-ish, and I am in no means an expert. I am not an electrical engineer, and I am not a college grad from Harvard and MIT. But when you read some stuff on the internet, they make you feel like you have to be to understand a simple antenna or which antenna you need for your first radio when you just get your license. Now, a lot of you watching are like, oh my gosh, a dipole, that was the first antenna I made 50 years ago. Right. This video is kind of geared toward the newcomers to the hobby who may not know, to try to just make this as basic as possible. And I'm going to use a couple products in my demonstration. Now, these products are not why I'm making this video, but I met Radio Waves again at Orlando Hamcation, and I said, hey, can you donate a couple of these and I'll show them in my video, so I have something to show, because I don't have a 10-meter dipole. I have a lot of dipoles, I just don't have one exclusively 10 meters. Now, the reason I picked these also is because there are two types of people in ham radio. Those that want to build everything they do, and those who don't want to learn how to build anything. They just want to buy whatever works and get on the air. And that is totally fine, because I'm kind of in the middle, all right? I've done my years of building antennas. I've built bazooka antennas. I've built dipole antennas. I've built verticals. I have built Yagis, cubicle quads. But then it comes to the point where you run out of time, and you've learned a lot of that, and then you want to buy something. But there is no magic when it comes to buying or building a dipole. It's a dipole. Now, a dipole is very easy to erect. It's very simple in design. It's nothing magical about it. And it can be used, toted in a backpack. Well, that's easy to tote, right? That's really small, just for 10 meters. But I want to show you how I'm going to set this up and give you an idea on what is making a dipole tick. And thank you for Radio Waves for donating these too. This is a 10-meter double bazooka, and this is a 10-meter dipole. Now, again, double bazooka, that sounds way better than a dipole. That's the magic. No, I'll show you what is different, because I was making double bazookas when I was 15 years old out of old cable TV coax for CB radio. Okay, I'm familiar with the double bazooka, and it's a very cool design. And they make these in other bands, 40, 20, 80, 160. They make all these. A lot of companies make dipoles. Maybe you want to build one first. Maybe you'll watch this video and understand that you don't want to buy this, you want to build it. Fine. Maybe you've built all those and you just want to purchase one. Great option here. But let's check out what is a dipole in the most simple, anti-professional YouTube manner that I am. The most mediocre way. A simple dipole. It's an antenna. What is it? Okay, I'll start with the Radio Waves 10-meter dipole. I'm going to give you a couple highlights here and explain that. It says measures 16.9 inches. Where did they get that number? Well, if you first got licensed and one of your questions is how to calculate the length of a dipole or an antenna for a specific frequency. How would you do that? Very simple. 468 divided by the frequency in megahertz will equal the length in feet. Okay, that was very simple, right? If you do 468 divided by 28.5, you're going to get real close to 16.9 feet. That is a half-wave dipole. What that means is, let's pretend I am the feed point. I'm the ballon. I'm going to show you that in a second. See, it comes with a ballon here, right? This is where you're going to connect your coax, and there's two cables coming off here. Ballon. We'll get to that in a second. So basically, I am the ballon. Ready? Now to make a half, the coax is connected to my feet. To make a half-wave dipole, you're going to have 2 quarter-wave lengths of antenna on each side. I am a half-wave dipole. Okay? You couldn't make a quarter-wave dipole because a quarter-wave dipole doesn't involve 2. Okay? So that's a half-wave dipole. If you divided that by 2, you'd get the quarter-wave length of an antenna, which would be about 8.6 feet, 8.7 feet for 10 meters, somewhere off my head. And that would be like a simple monoband or monopole vertical, something you'd put on your car, something you'd put out in the backyard. Okay, so half-wave dipole. Now a half-wave dipole can be done several different ways. This would be a top side horizontal dipole. And it would extend straight out, horizontal to the earth, and you would like to have it about half wavelength above the earth for at least a lower angle of radiation. Now, what is half wavelength above the earth if my half wavelength dipole is 16.9 feet? You got it. About 16 point something feet above the earth. Now, you can do this also this way. You could do a half wave dipole as an inverted V, like this. You may have seen inverted Vs like this. Inverted Vs are usually a couple, like 5% shorter than one that goes like this, okay? Now, the way a dipole radiates, it's not magic, it's not giving you gain, it's a very low gain antenna. It's probably the most practical to put up, but it's the most, I would say, inefficient when you're talking about versus a beam, right? When they say on this package of the Radio Waves 10 meter dipole, nothing beats a tuned dipole with its reliability and efficient performance. Why did they say that? Because that dipole is tuned to be efficient on 10 meters, okay? That does not mean you can just throw up any bit of wire and use an auto tuner and expect it to operate the same as a tuned 10 meter dipole, okay? A 20 meter dipole would be tuned, resonant, hopefully close to 1.1 to 1 SWR on 20 meters, 14 megahertz. If you did 468 divided by frequency 14.250, you would get around 32.4 feet. That would be a half wave dipole. That would be 16.2 feet on each side, okay? I only chose the 10 because it's shorter and it makes a little more sense to put it up in the backyard for now. And I love 10 meters. So, with that said, if you were to make your own dipole, what would be the difference between buying a dipole and making one? If you made it exactly like theirs, as far as the length and a 1-to-1 balun, nothing really. It just so happens that Radio Waves is in, they've made a lot of, they make the Sentinel hex beams, they make the cubicle quad I have in there, they make a lot of good stuff, okay? Emmett, the creator of all this stuff from years, if you're in ham radio for a while, you'll remember Emmett. Emmett has designed all these. Now, they did put this into a, manufactured form, okay, with a warranty and very low failure rate on these. But if you wanted to build your own, no problem. You could build your own. I've gotten to the point where if I want a 10 meter dipole, I'm going to buy one because regardless of what anybody thinks, I've built probably 50 of these in my day, and I've used every type of wire from phone wire to cable TV coax to beer cans to make a quarter wave vertical. I've done everything. Shopping carts and split them apart. I've done everything, okay? So, a 10 meter dipole. Remember, half wave like this, okay? Half wave inverted V like this. Which way does the dipole radiate? If you're talking to somebody and you have a dipole up, let's say this horizontal dipole is like this. And you can rotate the dipole like this, okay? The signal is broadside to the dipole. Meaning, if I turned this way, my signals, not in a directional beam kind of form, but a little bit more gain off the broad side of the antenna versus the tips, meaning perpendicular. My chest and my back would be the way that the dipole would be more efficient. So if you're in Florida, 9 times out of 10, your dipole would be arranged in an east-west form because really there's nothing 50 miles east of you and 50 miles west. You'd want to talk to South America and North America, right? That would be the direction that you would put your dipole. Now, if you turned it this way, I would be facing right now, my chest would be facing, west coast of the United States, Washington, and my back would be facing, South Africa, Cuba, somewhere that way, okay? That would mean this is the way that the signal would be more efficient for receive and transmit, and this way is the way that it would be least efficient, okay? What is this? This is called a rotatable dipole. Oh my gosh, what is that, Eric? There are units out there that you can buy that are a little metal. And let's say you want to make a dipole not out of wire, you want to use ham sticks. Ham sticks are essentially 2 quarter wave 10 meter antennas, which are compromised in size, but they're still electrically 10 meters, can be put on that, and you can rotate it to get a little more gain in one direction. Not much gain, not much, but a little bit, okay? But we're not gonna get into that. So, back to the radio waves 10 meter. Then we're gonna show you the double bazooka, all right? Now, this is very simple, very simple. This is a feed point, it's called a balun, a 1-to-1 balun. Basically, your coax is going to connect to here. It's got insulators that they made, which are made out of plastic, it looks like, ABS plastic maybe, and a wire on each side, okay? 8.4 feet of wire on each side. And what I'm gonna do is I'm gonna take this, I'm gonna put it up on my tripod, my carbon fiber mast. I'm gonna erect it up. I'm gonna lengthen these sides out, and we're gonna put it on an analyzer and show you the SWR is going to be minimal at one specific frequency on this dipole, depending on the length, all right? Now, at the end of a dipole, you always have insulators, which is what you're looking at here. I just started 3D printing my insulators because I didn't want to buy any more. But what this does is this keeps the end of the wire insulated from whatever it's attached to, okay? This insulator, basically you're going to tie a string to this and run it to a tree limb, run it to a pole, whatever. But you want to insulate this copper clad wire, which has your RF on it, to whatever it's attaching to. Do not tie it to a fence. Do not tie it to a metal pole. Do not tie it to a metal flashing on your roof. Do not tie it to a metal roof or even to a tree, because trees can get wet. They can cause, you know, fluctuations in your SWR and actually start radiating with the signal that's at the end of this line, okay? So you want to make sure that you're insulated. And look at this. So this insulator right here, see the way this is so that you can pull this real tight. You're not going to pull, this is the terminal. This is your one of these is your center of your coax, and one of these is your braid of your coax. So basically, it's just taking your coax, feed point in, it's got the 1-to-1 balun, it splits it, one side and the other, okay? So this looks pretty sturdy as far as the radio waves antenna, where you can mount this and pull that tight. You don't want it to really sag like this. You want it to be nice and straight. So different characteristics, but it's just a dipole. Okay, there are people in MIT that say, oh, this, and they'll go into some theory, man. There's no theory when you're a new ham radio operator. Make your dipole, buy a dipole, set up your dipole, get on the air. All right, so I have my Gigaparts tripod, my Gigaparts carbon fiber mast here, 34-foot push-up pole. I have to tell you, this has been outside now almost 2 years. Why? Because I'm lazy and I have nowhere to put it, and it's supposed to be my RV. I had my weather station on it, and this thing is still holding up. There's no splinters or spurs like there would be for fiberglass. This is discolored, but there's no rust on it. So it was a great thing they sent me. So thank you for that. For my celebration 2 years ago, they sent that. So here is the radio waves dipole here, and I have just a piece of wire here, and I'm using wires. I can't find string, but it's insulated, right? So I'm not touching anything through this insulator. Now what I'm going to do is I'm going to start pushing this up, and basically like this. There's one. Oh, there's water in here. I might want to keep that up, let it dry out. So what's a half wave length above the ground, folks? About 16 something feet. Well, I got to get my insulators on here. But okay, for 10 meters, you see. All right, so all I'm going to do is I'm going to run one wire this way, one wire that way. I'm going to try to get it out as far as I can, with some string or wire, whatever I got. And that's going to be about 16 feet up in the air. I'm going to attach my coax, and I'm going to put the analyzer on it and see what the SWR looks like, how broad banded it is. It always helps to have an SWR or antenna analyzer. Now, this is by far the most extreme that I can get, that Rig Expert had sent me a while ago. This is the AA2000 Zoom. This thing will tell me what any antenna is doing, the color of my underwear, and what I ate for dinner last night. This thing is really, really impressive. I'm using it right now for a simple antenna test on that dipole, and we're gonna see. Remember, The longer the dipole, the lower the frequency. The longer the dipole, the lower the frequency. So you always want to start out longer and cut a little bit at a time, okay? So we're gonna look at this here on the analyzer and see what the frequency is and which way I need to go and how much I need to cut. We'll do it a little bit and try to get it right in the center of the sideband portion, phone portion for technician class on 10 meters. So on my tripod here, now if you look at this, it really isn't much real estate talking about antenna. I did this the best way I could in my backyard with the tripod that I have. I used some yellow wires, so hopefully you can see where that's going. That's going over to a tree there, okay? And the other one is just over here on the bottom, on the ground here, on the end of the roll out here, just for weight. Now, I could have got it out farther and had it more, but we're just gonna do it as a V like this. And we're going to look and see what the SWR is, lower it down, make some cuts, and see where it goes and how much I need to take off and how it looks where I want it on the sideband portion of the frequency. So if I go to the 10 meter band on the Rig Expert and I hit start, watch. Okay, it has given me a chart here and showed me that the lowest SWR at 1.2 or less to 1.17 at 27.2. So guys, this thing is tuned right between channel 19 and channel 20, or actually on channel 20 of CB. That's too long. The longer the dipole, the lower the frequency. When you want it to go up, we want it to be up here. Look at the frequency on the top, right? We want it to be around, well, I do. I mean, if you're a tech, you're gonna want 28 to 28.5, so we'll call it 28.4 is the calling frequency. That's up there about 4 to 1, so we want to have that come down. There would be no reason for you to use a tuner on this. That would be silly. You cut the ends off a little bit at a time and get the resonant point where you want it. The next biggest mistake you can make is not cutting the exact same on both sides. What will you do there? Well, this dipole half wave is exactly the same length on both sides. If you cut off 1 foot on one side and 2 foot on the other, I mean, we're only doing inches here, but to do twice as much on one than the other, now you're becoming to make an off center fed dipole. It's not center fed anymore, right? A good off center fed dipole I made before was 95 foot on one side and 45 on the other, 90 and 35. Yeah, 90 and 45. That'd be an off-center fed roughly for 80 meters, and that requires a 4 to 1 bound, and that's a whole different thing, okay? This is a simple half-wave dipole. So what I do is I take a ruler, and I'm gonna take this off here, right? And we're not gonna measure the whole wire because I'm pretty sure that in the manufacturing process, that's how they got the SWR right. It is measured exactly on both sides. So I'm going to take 1 inch off of each side, put it back up, and we're going to see how much it drifted from 27.2 and which way, you know, is coming up. Shorter the dipole, the higher the frequency. We're going to see which way the frequency goes, it should go. And what I'm trying to say is how much it goes off 1 inch, okay? Okay, I did 2 inches that time. 2 inches brought me up to 27.68. So that was 2 inches. That brought me from 2, 3, 4, 5, 6, 7, 8, roughly, yeah. So I'm gonna do 2 more inches on each side. That should bring me, no, I'm gonna do 1 inch on each side. And that should bring me to like 28.2 or something like that. So in an effort to keep the video as short as possible, I went and did 2 more inches, did one and then another one. It brought me up to 28 megahertz, 1.29 to 1 at 28 megahertz. And, you know, 1 inch on mine may be different than 1 inch on yours. But we're gonna go 2 more inches, and that's gonna hopefully bring me right to 28.4. Okay, so another about 2 inches off of it. I'm right at 1.35 to 1 at 28.44, which is totally acceptable, all the way up to, you know, a 3 to 1 at, wow. Yeah, so you could even do, if you wanted to maintain a 3.0 and less, looks like 29.4. So AM portion of 10 meters at 29.0 to 29.2 is covered under 3 to 1, but the best SWR is right here, down at 28.44, 1.3. And now if we go back, look, I could even do the sideband or the CW portion, FT8 portion at 2.1 or less. That is acceptable. And then you can use your built-in or external antenna tuner to clean it up and make sure your radio is happy. It's not going to tune your antenna, it's going to make your radio see a perfect 50 ohm 1.1 to 1 SWR. Remember, look at this, okay? And in the next video, we're going to do the same thing with the double bazooka, because the double bazooka is going to be much more broadbanded based on the size of the wires that are coming off of that antenna. I'll show you how that's constructed. In the meantime, if I go back, looking at this this analyzer here, let's see. No, I want this one. All parameters. Okay, start. So at 28.4, we're looking at 1.37 to 1. Return loss is 16.3 dB. The impedance is about 63 ohms. Now what that tells me is I might be a tad bit longer on one side than the other. So to get that a perfect 50 ohm right here, you would have a 1.1 match. You'd have a perfect antenna, but not bad there. I might have cut off just a tad bit off one side too much, but you get the idea. All right, so that doesn't look like too much real estate, right? You got one leg there that's only about 8 feet. One leg over here is only about 8 feet, you see? Right? Now, a 20 meter dipole would be twice as long as this. You're not counting this. This is not part of the antenna over here. It's just that. Just where you see it connecting right there. Not much, right? And now, if because of what I cut, if I did do this totally horizontal, now it's going to be probably too short. All right, because it's 5% shorter when you go to an inverted V, or just a little bit shorter when you close it in. When you're full out, well, you might want to cut it when if you're going to do, total horizontal up top, like that power line, picture it like that. You're going to cut it less because when you fold it down to an inverted V, you get the idea, all right? All right, so overall, there you have it. Well, what I want to say about these radio waves, I think they're great construction. You may have had these before. You may be saying, oh, it's just a dipole. They're constructed quite well. The way that looks up there, it's not going to be affected by weather much. The wire is super strong. I've had other dipoles where the wire breaks right in half. They use small PTFE wire. This is copper-clad steel, tight with a big insulator on it. It's not going to break real easy. So I'm very happy at those. They also gave me, because I requested this, okay, and that's going to be in a future video, they also gave me the cubicle quad. It does 2 meters of 440, super high gain. I want to have that for when the band opens on 2 meters and 440. I could talk up the East Coast of the United States again. I have my 13 B2 Cushcraft Yagi over there, but that cubicle quad is pretty cool. Now, I tried to make one several years ago, and it didn't work so well. I played with it, made it again, added some PVC and some wire. I got it working. The front to back ratio wasn't the best. I could hear people off the back just as well as I could hear them off the front. Just had a little bit of forward gain. This cubicle quad that Radio Waves has seems to be really, really a cool design. You got to see it with the ABS plastic, the 3D print things they made and stuff. It looks pretty cool. We're going to check that out in a future video. First, I'm going to make a video on this next, okay, the double bazooka, and show you the difference on the way the double bazooka is made and the bandwidth of that thing. You can go almost an entire 10-meter band off this antenna with minimal adjusting. I want to say this too at the very end. Thank you to my sponsors at HamRadioPrep.com, and check out the video coming soon of the American Radio Club that they've just announced. For people that are just getting into the hobby, you get your license at Ham Radio Prep. Maybe you use the code ERIC20 to save 20% on any course. That's what they do for my fans, and my friends, and my family, and my viewers too. If you're looking to get a license, HamRadioPrep.com, ERIC20 is the code, and you'll save 20%. But what happens after you get your license? Ham Radio Prep made American Radio Club That's what. There's going to be a lot of information, videos on there, making your first contact, forums, helpers, Elmers, all kinds of stuff. You'll see me on there, and that's a great place to not just go to YouTube, but you can go to American Radio Club and check them out too, because they really have a lot of information that they're trying to put. They just didn't want to get you to get a license and you disappear forever. They want you to stick around and learn some more stuff on this hobby. So thanks to Ham Radio Prep for sponsoring my videos. Thanks Radio Waves for giving me these, because hey, that was pretty cool for the effort of this video, and you know, to promote their product a little bit. Radio Waves, they have a lot of stuff. I want their Sentinel Hex beam on my tower one day, but that tower's been sitting there a year, guys. I still haven't got it up. Ain't had time. But a hex beam, that's way different than a dipole, and I hope that you get to see that one day on the top of my tower. So thanks everybody for watching. More videos are on the way. I hope this made it a little more simple. So what is a dipole? Why? What? Listen, I get amped up, but I just want you to learn. I just want you to be happy. I just want you to know that you don't have to be an engineer to learn ham radio, okay? 7-3. This is KJ4YZI.